Hello everyone, welcome to Fun with Learning. Today we will solve exercise 7.4 of chapter integration. Earlier to this video, we have solved 7.1, 7.2 and 7.3. Video is available on this channel of those exercises, you can watch it. Actually 7.4 exercise is more important than previous other exercises. In other exercises, all exercises were fixed with certain identities. In 7.1, it was fixed with method of inspection, and 7.2 was fixed with substitution method, and 7.3 was fixed with trigonometric identities. But here in this exercise 7.4, you can apply all those previous knowledge. So this exercise is like checking for all the previous knowledge that you have learned in the chapter integration. So let's move, we'll solve exercise 7.4. First question is integration of 3x square by x to the power 6 plus 1. In this integration, we can try both substitution method and trigonometric identities. So we'll try at first substitution method, because it is quite visible that this numerator is the differentiation of the denominator. If we take denominator is something like x to the power z to the power 3. So x to the power 3, differentiation of x to the power 3 will give me 3x square. So then I can use substitution method to solve this integration. So let's substitute. Let z equal to x to the power 3. So differentiation of dz with respect to dx, it will become 3x square. It will implies dz equal to 3x square into dx. So now I can substitute integration of 3x square upon x to the power 6 plus 1 dx is equal to dz by, and x to the power 3 z, so I can take, it will be z square plus 1 upon z square plus 1. I have replaced dx 3x square with dz. So now we'll be using the formula of x square plus a. So our answer will be, right now I'm using this formula, since integration of x square plus a square is equal to 1 by a tan inverse x by a. So here our answer will be 1 by, here a is 1, so it will be 1 upon 1 into tan inverse z by 1, since a is 1. And what is the value of z? We have to substitute in the form of x also, because answer should be in the form of x, variable x. So z will be x cube. So I can write tan inverse x cube plus c as our answer. You can check also here. So answer is tan inverse x cube plus c. Okay, it's fine. Now moving for second question. Oh, we can try here. See, there is no limitation which method you are trying in this exercise. Whatever method is coming to your mind, you must try. It will give you some clear picture, because in final exam you have to solve these all integration question by your mind. So none of the method that you are going to mug up will work in final exam. So let's try by trigonometric identities. What we can use, we have one formula, sec square x minus tan square x is equal to 1. Can I use this? I can try this. Sec square x equal to 1 plus tan square x we can write. So now we can see here, it is in the form of tan square x plus 1, and our differentiation will substitute here with something like sec square x. So what we can use, what we can do, we can assume let x cube as 10 square x. Just I'm trying, see if we are able to solve or not. Because math is all about you have to try different and different method, whether it is right or wrong. So we can do differentiation of x cube will give me 3x square, and differentiation of 10 square x will give me 2 into 10x into sec square x dx. Take x cube equal to 10 square y. Okay, so it will give dy upon dx. So it will give me 2 into 10x into sec square x dy upon dx is equal to 3x square. So I can write 2 10x into sec square x dy equal to 3x square into dx. So now what we can do? We can replace 3x square dx by this quantity. So it will become 2 10x into sec square x into dy upon, we can write, we have assumed x cube as 10 square y. No, we should have taken x cube as 10y. Okay, otherwise it will become wrong because I want 10 square plus 1. So the differentiation, now we have to differentiate x cube equal to 10y. So it will give me 3x square equal to, differentiating this with respect to y. Okay, 10y with respect to y, it will give me sec square y into dy upon dx. Okay, now it is fine. So we'll get dy upon dx equal to 3x square 3x square sec square y into this much. So sec square y into dy will give me 3x square into dx. Now I can substitute 3x square dx with sec square y into dy. So we'll get integration sec square y dy upon, as x cube equal to 10y, so x to the power 6 will give me 10 square y plus 1. Now you can probably see what is why I was doing using these trigonometric identities. Obviously now I can substitute something is equal to 10y. I will substitute let z equal to 10y. Implies differentiation of z with respect to y will give me sec square y dy. So I can substitute dz equal to, yes. So directly I'm substituting dz equal to sec square into dy. So here I will get dz upon 10. I have taken a z, so it will become z square plus 1. So again it is in the form of z square plus a. So here again I will use same formula to get answer. 1 by a is a is 1. So 10 inverse z upon 1 equal to, now I have to substitute the value for z. So what is the value of z? Z is equal to 10y. 10 inverse 10y, 10 inverse 10y, and what is value of 10y? 10y equal to x cube. So here it was plus c plus c. So 10 inverse 10y equal to x cube plus c as our answer. So here we have substituted 10y equal to x cube. So again see, answer is same. Answer will be same whether you apply any method. So here we have used these two methods. You can try some other trigonometric identities if you wish. Now I'm moving for second question. This question is quite clear. We can use directly here formula. Again, here you can apply some trigonometric identities if you wish. You can try, you can make some error, but you will learn something. So try to do by yourself. Right now I'll be using here directly one formula that is available to us in the exercise. That is, we have formula integration of 1 upon under root x square plus a square equal to, it is log x plus under root x square plus a square. I hope I'm right. Okay, so this is formula. So integration of 1 upon under root 1 plus 4x square dx. Although here I can use substitution method to make in the form of this identity, but there is no need of this. Directly we can use formula by comparing. Here it is 1 square, that is 1 square I can write, plus 2x square dx. So it is in the form of x square plus a square in under root. So I will directly, our formula will give us log x is 2x, so we'll get 2x plus under root x square, again I will get 4x square. Our a is 1, so I'll get 1 plus c, but here 2x is there, so once I will differentiate it I will get 2, but here it is integration, so I'll send it in downwards. So our answer should be 1 by 2 log 2x plus under root 4x square plus 1 plus c. So we can check answer is 1 by 2 log 2x plus under root 1 plus 4x square plus c. We can write 1 plus 4x square or 4x square plus 1. It is same thing. Answer is same. So now moving to third question. Again here it is in the form of x square plus a square. We can write this as 1 by 2 minus x square plus 1 square dx. Directly you can use formula. The same formula will be using x square plus a square. So it will give us answer log x, but here x is, you need to see what is variable. Here variable is 2 minus x, so I need to put 2 minus x plus under root. There is no need to always substitute. You can substitute at first z equal to 2 minus x, then you will be writing z square plus 1 square. There is no need, directly you should do it. 2 minus x square plus 1. But now our variable is 2 minus x. Now you need to differentiate it. By differentiation you will get it. Differentiation of 2 is 0, and then differentiation of minus x, it will give you minus 1. So you need to put it here, minus plus. So it is our answer. You can check this. So third answer is 1 log 1 upon 2 minus x under root x square minus 4x plus 5. Okay, what we are getting. Okay, they have expanded this and they have used this negative, they have brought this in inside. See, this is the property of log. Actually they are using log, if this is base a, x to the power n, it goes outwards, log a to the base a x. If power is there on x, it goes outside in multiplication. But if it is power on base, like if I am putting power on this, here this n power is on base. So what I am writing here m, okay, for not for like your convenience. So here what I will do, I will send this m as outside with m in denominator, log base ax. So there is difference between n is power to what, whether it is power to base or whether it is power on x. So again I will send this minus to the to inside. So I will get log 1 upon 2 minus x plus Now I will expand it. The identity is a minus b ka whole square. So I'll get a square plus b square minus 4x plus 1. After solving it, I will get log 1 upon 2 minus x plus x square minus 4x plus 5. So now we can check again. Log 2 minus x square minus 4x plus 5, it is right. Okay. So now moving on to next question. You can write here answer. Again, this question is clearly visible. Although you can try some better methods, you can try to put some trigonometric identities. See, basically there are 2-3 trigonometric identities you can apply. One is in the form of sec square theta minus tan square theta equal to 1. Sin square theta plus cos square theta equal to 1. And cosec square theta minus cot square theta equal to 1. You can apply these three identity to solve various types of integration. See, everybody would be using this formula, but if you use this type of, actually the formula, these all we have derived by using trigonometric identities only. Once you will check the proof of this in this exercise, you will get they have used trigonometric identities. But once you use in question solving in front of teacher, really it gives some like good impression. So right now you can apply. It is in the form of 3 square minus it is 5x whole square. I'm not saying that you'll always be able to try trigonometric identities, but you can if you wish. Try it, do some error, you can learn it. So it is in the form of a square minus x square. The formula of a square minus x square is 1 by, no, it is sine inverse x upon a. So what is x here? Variable is 5x and a is here 3. So we can write sine inverse 5x upon 3. But now problem is we have variable as 5 into x. So what we will do? We'll differentiate it 5x. So after differentiating, what we'll get? 5 as outside. Since it is integration, so we'll write 5 in denominator. So I'll write sine inverse 5x upon 3 and I will send 5 as denominator plus c as our answer. So we can check 1 by 5 into sine inverse 5x upon 3. So it's right. So now we can move on to next question. Fifth question is, what we can do here. Now you need to see whether you can use substitution method or not. If you take x square and you find differentiation of x square, you will get 2x. Yes, in numerator x is there. So you can try it once. And again, once I will take x square, it will give us something a square plus x z square, some other variable. So we can use then our formula that is there in this chapter. So let z equal to x square I am taking. But what I will do at first, I will send 3 in outside because I don't need 3 in numerator. 1 plus 2x to the power 4 dx. So I have taken z equal to x square. So differentiation of z with respect to x, it will give me 2x. I am writing directly dx. Now dz upon 2, it will be x dx. So now what I will do, I will substitute 3 into x dx as dz upon 2. So I am sending 2 as outside. So it will give me 1 plus 2 into, and what x square is equal to z. So it will give me z square. So I can write 3 by 2 into dz upon a square, means 1 square plus under root 2 z square that is x square plus a square. I am saying in the form of formula that is there. Here variable is z square. Okay. So formula we had equal to 3 by 2 into, we have formula for this, 1 by a. So 1 by a is a 1, so it will become 1 by 1 into tan inverse. Tan inverse, what is variable? Variable is here root 2 into z. Tan inverse x upon a. Again a is 1. So now our variable is under root 2 into z, not only z. So you need to find differentiation of this. So differentiation of this, it will give me under root 2. Okay. So now it is, since it is integration, so I will send root 2 into denominator. So I'll get root 2 plus c. So our answer will be 3 by 2 root 2. Okay. Tan inverse root 2 into z plus c. But you cannot write this as answer. You need to replace z with x in terms of x, because our question was in the form of x. Always try to do that. Otherwise, teacher can cut 1 or 2 marks for this thing. Under root 2x square plus c. You can check answer also. This one is fifth number. Fifth number is 3 by 2 root 2 tan inverse root 2 x square plus c. Okay, it is right. We can write here answer. Now we can move for sixth question. Again, here what we can do, try to see what is numerator. If it is x square, how to get x square, how we can substitute x square. Obviously we can take, once we will take some variable equal to x cube, we will be able to substitute x square. You should not be worried about constant. You can always send constant outside of integration. So again I will do same thing. I will substitute. I will let z equal to x cube. So differentiation of z will give me 3x square into dx, but I don't need 3 in numerator. So what I will do, I will substitute with dz upon 3 equal to x square dx. So I'll get integration x square into dx as dz upon 3. So I'm sending 3 in outside. So it will give me 1 minus x cube is z. So x to the power 6 will give me 1 minus z square. Now here you can use formula. I'm writing here formula. The formula for integration 1 upon x square, it is a square minus x square. So a square minus x square is log 1 by 2a. Okay, 1 by 2a log a plus x into a minus x plus c. Okay, this is our formula. So you can use this formula to get your answer. This is 7th number question. Again in this question what we can do, we could have applied substitution method, but the differentiation of x square minus 1 will give me 2x, only 2x. So but here x minus 1 is there, I cannot use substitution method directly. But what we can do, we can apply some x equal to sin theta also, but cos square theta, it will give me cos theta then sin theta. It is in same way. We cannot use here directly substitution method, but what we can do, we can separate this integration into two parts. See, then it will become quite easier. I can write x upon x square minus 1, okay, dx. Minus I'm sending outside, so I'll get minus 1 under root x square minus 1 dx. This part you can try by yourself. It is directly based on the formula. I'm writing a formula for integration 1 upon x square minus a square. It will give me log x plus under root x square minus a square plus c as our answer. It will be our answer for this part. But now we need to solve the first part. Again, this part is quite easier. We have solved this type of integration in some of question. What we can do, we can substitute, let z equal to x square minus 1. I can take directly. So what it will give me? Differentiation of z with respect to x, it will give me 2x. But I need here only x. Obviously, we can throw this 2 outside of integration. So I'll write dz equal to x dx. So now I can substitute x dx as integration dz upon, I can send to outside. So it will give me under root z. So now you can integrate this part also easily. Integration of this part, it will give me, it is z to the power minus 1 upon 2. So integration of it, it will give me z to the power, there will be addition of 1. So it will give me 1 upon 2 and then division of by 1 upon 2 plus c. So I can cancel 1 by 2 and 1 by 2. So it will be under root z. But now you need to substitute for under root z. It is x square minus 1. X square minus 1 plus c. Then you will solve for similarly for second part also. Then you will sum up and the sum will be, actually you will subtract because minus sign is there. Then this subtraction will be total answer. Here it is only first part, so it won't be answer. Again, you need to find for second part that by using the formula. So summing up will give you the answer. This is 8th number. Again here, I think now by 8th number you would be knowing how to solve this type of integration. You must be going for substitution method, but here we can apply some trigonometric identity also. Same way what we will do, we will take x cube as tan theta I can take as in the first number I had taken, or what we can do, we can substitute let z equal to x cube. So right now I am moving with z equal to x cube. So z equal to x cube will give me differentiation of z with respect to x, it will give me 3x square into dx. I don't need 3 in numerator, so I will transpose 3 into LHS. So it will give me dz upon 3 x square dx. So I'll get x square dx as dz. I'm sending 1 by 3 outside. So it will give me as x cube equal to z. So it will give me z square plus a to the power 6. Okay, there is no problem. What I can do, it since it is constant, so there is no problem. I could have tried some other thing, some other substitution like z equal to, I could have taken a cube into x cube, then it would have been much more better. But right now there is no problem. This is also fine. I can do z square plus, I can write a cube square. I can do this. Obviously I can do this. So the formula for this will be 1 by 3 into, it will give me under root z square plus, so the formula for this is what? It is in the form of integration 1 by x square plus a square. So it will be log z plus under root log x plus under root x square plus a square. It will give me 6 a to the power 6, and differentiation of, since it is constant, so there is no problem at all. Okay, so it should be our answer, but I need to replace z with x also. Z equal to x cube is there, so our answer will be 1 by 3 log z plus, and no, it is not z, it is z equal to x cube. So x cube plus under root x to the power 6 plus a to the power 6 as our answer. So this was 8th number. And our answer is 1 by 3 into log x cube plus x to the power 6 plus a to the power 6 plus 6 answer. Okay, 1 by 3. Okay, it's fine. X cube. It's good. So this is our answer. Now we can move on to 9th number. Now you can guess. See, again here they have given question in the form of trigonometric identity. So once you will keep on trying to solve normal question by trigonometric identity, now you can solve this question by, you know what to take, how to substitute for this question. Now what you can do, you can take let z equal to 10x. The differentiation of 10x with respect to x, it will give me 10x equal to sec squared dx. So now I can write, I will substitute sec square x into dx as dz upon, it will give me 10x as z, so z square plus, I can write 4 as 2 square to use my formula. So it is in the form of x square plus a square. So directly I will write log z plus under root z square plus 4. Now you need to substitute in terms of x. So it will be log 10x plus under root 10 square x plus 4 plus c as answer. I hope it should be answer since it was so easy. Okay, yes, 9 number is log 10x plus 10 square x plus 4 plus c. So now we can move on to 10th number. Again, see, this is under root quadratic equation is there. It is a polynomial. So what we can do, we will try to convert this polynomial in the form of either in the form of x square minus a or x square plus a or a square minus x square, because a square plus x square will be same thing by abelian property, because addition is, we can change it, we can write x square plus a square or a square plus x square with respect to addition. So both are same thing. So this three thing we'll try to get it from quadratic equation, then we'll apply the formula that is given in our book. So right now what we can do, yes, it is in the form of, right now I'm just directly trying how to solve quadratic equation, how to change quadratic equation in the form of our formula. So x square plus 2x plus 2 is there. I can write x square plus, that is a square, I'm using this identity, a plus b ka whole square, a square plus b square plus 2ab. It is x square, it is fine, plus, now it is there 2 into a into b. A is x, it is fine, but b is 1. So I need b square also. So b square will give me this, but it was not from earlier, so I'll need to put minus also, plus 2. So what I'm getting x plus 1 ka whole square, okay, in minus 1 plus 2. After solving, I will get x plus 1 ka whole square plus 1. I can write x plus 1 ka whole square plus 1 ka square. In final board exam, this type of question comes involving in numerator px plus q. It was there in during my exam of board. So I will get x plus 1 ka whole square plus 1. Now it is in the form of x square plus a square. So I will write here integration 1 upon, since I have converted this quadratic equation in the form of this expression, so I will write directly x plus 1 ka whole square plus 1 ka square. So now I can use directly formula, although we have solved one question of this type. Directly we can write, so it is x square plus a square, we will write log x, what is x here, but here variable is x plus 1. Try not to forget it. If you are getting difficulty, you can then substitute, you can let, right now I'm just showing for one question. What we can do, we can take let z equal to x plus 1. So differentiation of z with respect to x will give me dx. It will be now, it will be same thing, but it will be in the form of formula. So it will be z square plus 1. So I can directly now write log z plus under root z square plus 1. This should be our answer. Huh? In the terms of x I need to write. Okay. So it will give me log x plus 1 plus under root x plus 1 whole square plus 1 plus c as our answer. So now we can check answer for this is our 10th number. Okay, yes, this is 10th number. 10th number answer is log x plus 1 x square plus 2x plus 2. I think it is fine. Now you can expand it. It will give you x square plus 2x plus 2. Okay, it is fine. So this is our answer. So now again we are moving on to similar question is there, but here root is not there. But concept is same thing. Now you need to convert this quadratic equation in the form to again in the form of x square plus a square or x square minus a square or a square minus x square. So right now I'm helping you in converting this because it is new concept 6x plus 5. So we can write a square. This formula I'm using a plus b ka whole square as a square plus b square plus 2ab. So it is fine. A square plus 2 into, always write at first 2 into a into b. It will give you what to take as b. 2 into 3x. 2 into, this is a, this is a. 2 into a into b. What will be b? It should be 6x. So already we have 6x. So I can take 1. So once b is 1, so I can take b square also minus b square also, because there should be no effect on real expression. So I will get 3x plus 1 square minus 1 square plus 5. So after solving I will get 3x plus 1 square minus plus 4. So it is equal to 3x plus 1 square plus 2 square. Not in the form of x square plus a square. So I can write integration 1 by, I am directly replacing this polynomial quadratic equation with this expression. So I'll write 3x plus 1 whole square 2 square. The formula for x square plus a square is equal to 1 by a. What is a here? A is 2. Okay, so 1 by a into 10 inverse. Now variable is x is 3x plus 1. This whole is variable, not only x. So I'll write 3x plus 1 upon a is again 2. But I need to differentiate also because our variable has changed. See, since variable is not only some particular z or x, there is some coefficient with z also. So I need to differentiate. I'll get 3, so I'll send them on to denominator. So this will be my answer. 1 by 6, 10 inverse 3x plus 1 upon 2 plus c as our answer. I think it was which number? It was 11th number. So now we can check for answer. 11th number is 10 inverse 3x plus 1 upon 2. What we are getting? Okay, 1 by 6, 10 inverse 3x plus 1 upon 2. So it is right. So now we can move. Twelfth number is again same quadratic equation is there. What we'll do, we'll try to convert this quadratic equation again in our expression that is needed, required expression. So we have quadratic equation 7 minus 6x minus x square. The problem is, since minus is there with x square, so it is creating one problem. So what we can do here, we can write here 1 upon under root. I can take minus as common, so it will give me quadratic equation x square plus 6x minus 7. Now I will solve for this quadratic equation, and at last I will change minus into required form. So I have quadratic equation as x square plus 6x minus 7. So I can write this x square plus 2 into, okay, 2 into what is a here? A is x, 2 into x. I need b as 3. So it will give me output as 6x. But I need b square also. It will give me b square minus, also it is needed since I am adding extra thing. So this will be minus 7. So it will give me x plus 3 whole square. A square plus b square plus 2ab minus 9 minus 7. After adding I will get x plus 3 a square minus 16. I can write x plus 3 square minus 4 square. So now I have quadratic equation. I can write x square plus 6x minus 7 as this expression. So I'll replace this quadratic equation by required expression. So I'll write minus sign, I will take x plus 3 whole square minus 4 square. Okay, is dx. Now I can write dx upon 16 minus x plus 3 whole square. Now you can directly use formula. I'm writing just formula, then you have to use that formula to get answer. So it is in the form of, I can write at first dx integration a square minus x square, and the formula for integration dx upon a square minus x square is sine inverse x by a plus c as answer. So this was 12th number. Okay, now we can move on to 13th number. So it is 13th number. Here it is in the form of x minus 1 into x minus 2. So what we'll do, we'll multiply them, we'll expand them to get some quadratic equation. It will give me 1 upon under root x square minus 2x, okay, x into minus 2 minus 1 into x, it will give me minus x plus 2 dx. So it is going to give me dx upon under root x square minus 3x plus 2. Now it is again a quadratic equation. I hope you can solve it directly. What will you do? You will convert. Okay, I'm just helping you in converting. So it will give me minus 3x plus 2. It is going to give me x square, and yes, it is a bit problematic. Okay, so I can write minus 2 into what is a is x into, I need now 3 here. So what I will do, I will write 2 here to cancel this and 3 upon 2. So this will be our 3 upon 2 is my b. So I can write 3 upon 2 as b square minus 3 upon 2, extra term is there, so I need to subtract also, plus 2. So I can write x minus 3 upon 2 whole square minus 9 upon 4 plus 2. So it will give me x minus 3 upon 2 square plus, I'm writing 4, I'm taking LCM, it will be 9 plus 8. So it will give me x minus 3 upon 2 square minus 1 upon 4. So it will be x minus 3 upon 2 square minus 1 upon 2 square. Now I will use directly formula after replacing given quadratic equation. So I can directly write integration dx upon, it was in under root, so x minus 3 upon 2 square minus 1 by 2 square. So its integration will give me, it is in the form of x square minus a square. So I'll get log x plus under root x minus a square. This should be our answer. Although we need to expand, it might be in answer. They would have expanded. So now we can check answer. This was 13th number. X minus 3 upon 2. Yes, here they have expanded it. X minus 3 upon 2. So it is our answer. You can expand it. There is no problem. So now we are moving on to 14th number. Again, it is a quadratic question. I hope you can solve it, but at first I'll just convert this quadratic equation in the form of in the required form, so you can use directly formula. What I will do, I will take common. Whenever minus x square is there, you need to take minus s common so that it will not create problem for later on. So minus I have taken common x square minus 3x minus 8 it will give me. Okay, yes. So now I have quadratic equation x square minus 3x minus 8. So x square, that is a square, minus sign is that 2 into a is our x, b what will take? You can guess. B should be, I should get 3x as our output. So I need to place 2 in denominator so that I can cancel 2 and I can get 3. So 3 upon 2 is our b. Again I can write 3 upon 2 square. Again I need to subtract also, minus 3 upon 2 minus 8. So I'll get x minus 3 upon 2 square. This much it is fine. I can write 9 upon 4 minus 8. So I will get x minus 3 upon 2 square minus plus minus 9 minus 32 upon 4. So it is x minus 3 upon 2 square minus, it will give me minus 41 upon 4. So I'll get x minus 3 upon 2, I can write as minus under root 41 upon 2 square. Now it is in the form of x square minus a square. I will replace this quadratic equation x square under root is there with required expression. So I'll get integration 1 upon, minus sign was also there, minus x minus 3 by 2 square under root 41 upon 2 ka whole square. I am leaving on to you. Since it is in the directly, now you can use formula for, at first you need to open it up because minus sign is there. So it will give you a square minus x square formula. So directly you can apply, you will get in terms of sine inverse. Since it is the formula, I am just writing integration under root a square minus x square was equal to sine inverse x upon a plus c was our answer. This chapter is totally based on formula, so it becomes very easier. You know, anyhow you have to reach on to some required form, either on x square minus a square, or it can be under root also. Once you are able to reach there, you can directly use formula. But then you can apply some trigonometric identities also, another thing, inspection method or any other method that is coming onto your mind. Now moving on to next question. It is 15th number. Although we have done this question, but since it is in the form of constant, so it becomes a bit harder for a student to solve it. So what I will do, I will expand this at first. It will give me x square minus bx minus ax plus ab. Okay. So I'll get dx, I'm writing here, dx, it will give me x square, under root it is there, x square, I will take minus x as common, so it will give me a plus b plus ab as constant. So now I need to change given quadratic equation in the form of, in required form, so that I can use formula. I am writing directly quadratic equation, I am giving them as equation 1, x square minus x into, you can separately solve quadratic equation at first, because Why to write keep on writing integration so many times? It can make you to do some error. So try to solve quadratic equation at first. At least convert them into required form. X a square minus 2 I'm writing here 2 into a into now I need to write b. So obviously a plus b has to be there, but I need output as x into a plus b, so I need to cancel 2 also. Now a plus b upon 2 is our b, that is a plus b ka whole square identity I'm using. So it will, I need to write a plus b upon 2 ka whole square. I'll subtract also since it is extra term plus ab. So I'll get x minus a plus b upon 2 ka whole square minus plus I'm taking writing here 2 I have taken as 4 I have taken as LCM from these two expression. So it will give me, I'm opening it up, a square minus b square minus 2ab plus 4ab. I have taken minus negative inside, okay, just to make it more easier. X minus a plus b upon 2 whole square. Yes, so now I can cancel 4ab. So I can cancel them as minus a square minus b square, and it will give me plus 2ab upon 4. So now I can write x minus a plus b upon 2 ka whole square. Yes, it is right. Plus I can take minus common so that it will be in some better form. So it will give me a square plus b square minus 2ab minus a square plus b square minus 2ab upon 4. Now I can write x minus a plus b upon 2 whole square minus a minus b upon a minus b ka whole square. It will give me a square plus b square minus 2ab upon 2. I can directly write whole square. So now it is our required expression. So our integration was under root. Okay, so directly I will replace a given quadratic equation with required form. So it was 1 upon under root was there. So under root I am directly writing x minus a plus b upon 2 whole square minus a minus b upon 2 whole square. So now it is in the form of our formula. We have one identity, that is integration of dx upon x square minus a square, and the formula we have equal to log x. Our x is x minus a plus b by 2, x minus a plus b upon 2. This is our x, plus under root x square minus a square. So we have x square minus a square. Since there is no coefficient with x, so there is no problem. There is no need to differentiate it or something like that. A minus b ka whole square. So this should be our answer. Although now they must have expanded it. So even after expanding, I will get the same quadratic equation, x square. So I'm directly writing same thing. So it will give me answer as log x minus a plus b upon 2 plus under root x minus a into x minus b as our answer. This is 16th number. Now this integration is a particular type of integration. It is in the form of px plus q upon under root quadratic equation, that is ax square plus bx plus c. It can be so much lengthy also, it can be very easy also. It depends totally upon question. So It is something like you need to keep on trying. Then only you can tell what is the intensity of question, how much longer it can go. When I was in class 12th, in final exam, there was one question like this: px plus q upon under root x square plus b square bx plus c, and it had taken, I think, almost 5 to 6 pages. It can be so much longer. So you need to practice this type of question more than 10 times. More than like 20-30 question of this type from RD Sharma or KC now you can try. Since there is no like limitation, each question will, once I will change one number, totally question will become different. So right now I'm watching, can I substitute something? See, if this has to be easier question, what we can do? We can substitute, we can take this denominator as z, and then we can try to substitute. See, we need to check this. So I'm taking z equal to 2x square plus x. If this question is easy, so it will be done by substitute method, then we can apply. If it is not easy, then we'll see what we have to do. Differentiation of z with respect to x I can get. I'm just checking. So 4x plus 1 I will get. Okay, yes, I can substitute it. So it is quite easier question. So examiner is happy. That's why he has given you so much easier question. I can take let z equal to 2x square plus x minus 3. Try to take whole this denominator as z. Don't take 2x square plus x as z. Although then you'll be then too you'll be able to substitute. But then there will be some problem. You will get something like z minus 3. So it will create problem. You won't be able to solve further then. So now I'm substituting z, differentiating z with respect to x. I will get 4x plus 1 into dx. Now I'll substitute 4x plus 1 into dx with dz. So I have got under root z. Integration of this will give me z to the power minus 1 upon 2 is there. So I will get z to the power 1 upon 2, and I will divide also by 1 upon 2. So it is c. So I'll get 2 into z to the power 1 upon 2 plus c. And what is z? Z is equal to some quadratic equation. So it will give me 2 into under root 2x square plus x minus 3 plus c as our answer. It should be our answer. We can check it. It is 17th number, I think. 17th or 16th. It is 16th number. Answer is 2 into 2x square plus x minus 3. I hope it is right. Yes, it is right. So it is done. So now we are moving on to 17th number. Always try to see at first whether it will be done by substitution method or not. Then only try for other identity that is there in this chapter. So once you will differentiate this denominator, it will give you 2x, only it will give you 2x. So you cannot substitute it directly. But then I'm not telling you to apply given formula in this chapter. Try to apply as much as it is possible. Try to go for substitution method, because it is quite easier. Otherwise it will take more than 3-4 pages. So here what we can do, we can separate given integration into two integration to make this question more easier. It's x square minus 1 dx plus integration 2 into under root x square minus 1. I'm not going to solve this second part. Obviously you have to solve it, because it is in the form of x square minus a square, and you can throw this 2 outside. So obviously you'll be able to solve, I hope. In first part integration, again this you can try, but here it is, this part is easier. You can substitute let z equal to x square minus 1. Don't take only x square. It will be very problematic. Take whole as z. Then it will be very easy to integrate 1 by under root z. So after differentiating z with respect to x, it will give me 2x dx. So integration of x into dx will give me dz upon 2. So integration, I will replace x into dx by dz. I will send 1 by 2 outside, and then I will have under root z. So integration of under root z, 1 upon under root z will give me z to the power 1 upon 2. I will divide also 1 upon 2 plus c. I will cancel 1 upon 2 and 1 upon 2. It will give me z to the power 1 upon 2. So what is z? Z is equal to z is equal to x square minus 1. So I will get under root x square minus 1 minus 1 plus c as our, no, it is not answer, it is first part only. Now you will have to add second part to get your answer. So now I'm moving on to next question. So it is 18th number. Can I solve this question by substitution method? I need to check it. Differentiation of 3x square will give me 6x plus 2. Yes, I cannot solve this question by just by substituting, because numerator is not in the form of 6x plus 2. So now this question has become lengthier. Now examiner is not happy. It is going to take your more than 10 to 15 minutes, or more than maybe 15 minutes if you make some error. Then too you will not get your 6 mark or 5 mark, whatever it is. So be careful with this type of question. Try to solve maximum number of such question. Although it is lengthy, so we'll try to avoid. I know everybody does. So how to solve this type of integration? What we do? We have particular method to solve this type of question. It is in the form of, I am giving you type. It is in the form of px plus cube, and we cannot use substitution method here. Then x square plus bx plus c. So what do we do here? It is going to take more pages, so I'm drawing one line here. Okay, so now I have question. Yes, so what do we do in this type of question? We write numerator. Here numerator is px plus q, so I'll write px plus q as a is some constant, a into d by d upon x, differentiation of denominator, that is differentiation of quadratic equation, whatever it is in denominator, plus some constant b. Why I'm doing this? Because in maths always there is logic. We don't do anything for free. So why I'm doing this? Once I will write a given numerator in the form like this, a plus b, then what I will do, I will separate a plus b as 2 integration, and obviously then this part I can solve easily because I will solve it by substitution method. Yes, and this second part, it is constant, I will throw b outside, and I will solve quadratic equation with by, as usual, normal, whatever identity is there in this chapter. So now we will try one or two question of this type. Our question, we have 5x minus 2. So I'll write 5x minus 2 equal to a into, what is quadratic equation we have? D by dx quadratic equation we have 3x square plus 2x plus 1. So differentiation of quadratic equation will give me a into 6x plus 2 plus b. Okay, it is fine. Now I'll find the value of a and b. So I'll get 6ax plus 2a plus b. Can you find value? We'll be using elimination method to solve such equation. We'll compare both LHS and RHS. Comparing, see, just to find value of a and b, see how much it will go longer. It will take 1 or 2 pages in this only. Comparing both sides, we get a coefficient of x is 5 in LHS, and coefficient of x in RHS is 6a. So I'll directly write 6a equal to 5. So what will be a equal to? A equal to 5 upon 6 I got. And comparing both sides again for constant by coefficient of x, I have compared coefficient of x. So by comparing constant, I will get 2a plus b equal to minus 2. See here there was no need of elimination method. We have directly used it. It was easy. So we are able to find a and b easily. A is 5 upon 6 plus b minus 2. So I can write b equal to minus 2 minus 5 upon 3. So I will get 3 as LCM minus 6 minus 5. So I will get minus 11 upon 3. F, I will replace 5x minus 2 as 3x square plus 2x plus 1 dx. I'll write here 5x minus 2 as a into 6x plus 2. Obviously, I will not solve this. I was solving it. There was no meaning to solve it. So it is 3x square plus 2x plus 1. It is dx. So now what I can do, I will put the value of a and b. Our a was 5 upon 6. So I'll write 5 upon 6 into 6x plus 2 plus, and our b was equal to minus 11 upon 3. So minus 11 upon 3, 3x square plus 2x plus 1 dx. So now what we can do, I will just separate this this integration into two parts. So I'll write, I'm sending 5 by 6 outside, 6x plus 2, 3x square plus 2x plus 1 dx minus 11 upon 3 dx upon 3x square plus 2x plus 1. So now I can use substitution method for first part, and I can use quadratic equation for the second part. So what I will do, I'll write 5 by, let me use substitution method. Let z equal to 3x square plus 2x plus 1. So I'll write dz upon dx equal to 6x plus 2. So I'll write dz equal to 6x plus 2 into dx. So I'll write here equal to 5 by 6 into, this is dz. I'm substituting 6x plus 2 into dx as dz, and z equal to, this quadratic equation is there, so I'll write z minus 11 upon 3 is there, and now I'll solve this as quadratic equation is there. So 3x square plus 2x plus 11 equal to 5 by 6. We all know that integration of 1 upon z is log z. So it will give me log z minus 11 upon 3. It is 3x square. I cannot convert the given quadratic equation in the form of required form. So directly. So to convert them into required form, what I will do, I will take 3 as common. So I'll write into 1 upon 3. I'm taking 1 upon 3 as outside, dx x square plus 2 by 3 into x plus 11 by 3. So 5 by 6. Now I'll substitute for z, whatever z was equal to, because I need answer in form of x. Z equal to 3x square plus 2x plus 1. So it will be 3x square plus 2x plus 1 minus 11 by 9 into integration of dx upon, I can write directly, I'm using here quadratic equation, I'm converting it into the form of x square plus a square or x square minus a square, whatever it can be. So it is x square plus 2 into a into, what is b here, 1 upon 3. So I'll add 1 upon b square, so it will be 9 minus 1 upon 9 plus 11 upon 3. So I'll get 5 by 6 log 3x square plus 2x plus 1 minus 11 upon 9. It will give me dx upon x plus 1 upon 3 a whole square. A square plus b square plus 2ab. Okay, it's fine. Plus I will take LCM. It will give me 9 minus 1 plus 3 into 3 times. It will give me 33. So I will get 5 by 6 log 3x square plus 2x plus 1 minus 11 upon 9. So it is going to give me dx upon x plus 1 upon 3 the whole square. After adding I will get plus 3 I am putting as square, and 33 minus 1 it will give me 32. So under root 32 upon 3 ka whole square. I will get something like this. So now I can use here the formula of x square plus a square. So I'll write here 5 by 6 log 3x square plus 2x minus 1 minus 11 upon 9 into, it is in the form of x square plus a square. So integration of x square plus a square is 1 upon a. So it is 1 upon under root 32 by 3 into tan inverse x plus 1 upon 3 by a is under root 32 upon 3. So we can check our answer. So it was 18th number, I think. Yes, it is 18th number. The answer is 5 by 6 log 3x square plus 2x plus 1. 5 by 6. So we have 5 by 6 log, it is right. Minus 11 by 9 it is there. So I can cancel 3 times. So minus 11 upon 3 into under root 32 it should have. Minus 11 upon 3, it is good, but it is root 2. 3x plus 1 upon root 2, the answer is there. 3x plus 1 upon, at the place of under root 32, in answer root 2 is there. So I think we have made some error. 3x square plus 2x plus, what was our quadratic question? Oh, 1 is there. So I've written 11. Okay, here I've made an error. So this is why this type of question you need to practice. After doing so much of thing, if you make some error, it will give you just 0 marks. So it will be just 1 plus 1 upon 3. One upon 3. So I will get 1 upon 3. So minus 1 into 3. Yes, I got root 2. So I'll write minus 1 plus 3. So I'll get 2 root 2. Okay, root 2 upon 3. So here also root 2 upon 3. So now I can write answer. I'm writing here answer. Okay. So answer I have got 5 upon 6 log 3x square plus 2x minus 1. I'm cancelling from 3 to 3 times. So I'll write minus 11 upon 3 root 2 tan inverse 3x plus 1 I will get. By 3 it will be cancelled after solving. So I'll get under root 2. So this should be our answer. I think I hope it is right now. So now we can move on to plus C also. So now we are moving on to next question. It is 19th number. Again, can we try substitution method? We need to see. At first, we'll expand denominator. So I'll get 6x plus 7 as x square minus 5x minus 4x plus 20 dx. 6x plus 7 x square minus 9x plus 20. Differentiation of denominator will give me 2x minus 9. So there is no advantage of using substitution method. So again I will have to use In similar fashion, 6x plus 7 equal to a into differentiation of dx x square minus 9x plus 20. Just here I will find the value of a and b, then I will leave on to you to solve. So what I can do, I will write a into, just you have to substitute 6x plus 7 by this expression, nothing extra. But we need a value of a and b. So I'll write here a equal to 2x minus 9 plus b. So I'll get here 2ax minus 9a plus b. So now by comparing I will get comparing coefficient of x both side we will get 2a equal to 6. So a will be 3. Okay, it is easier here. A is equal to 3 and by constant we will get 7 equal to minus 9a plus b. So it will give me 7 equal to a is 3, so minus 27 plus b. I can write b equal to 27 plus 7 is 34. So just I am replacing. So we had integration 6x plus 7 by 6x plus 7 by 6x plus 7 by x square minus 9x plus 20. X square minus 9x plus 20 dx. So now I can write a into differential coefficient was there, so I can write 2x minus 9 was there plus b upon x square minus 9x plus 20. Now it is done almost. Just you will put the value of a was 3, 2x minus 9. I'm just separating directly into two integration. X square minus 9x plus 20 into dx plus b is 34 x square minus 9x plus 20 dx. First integration you can solve by substitution method. Second, you can use a normal formula. I hope here this formula will be in the form of something like, you can use this thing, anything you can use, one of like 3. This 3 thing is available to you, this expression, you can use any one of the given integration. So this will be second part. After adding 1 and 2, you will get your required answer. Here you can proceed easily because we have solved part 1 also and part 2, some question related to it. Now it is 20th number. Okay. Again we need to see the substitution method whether we can use or not. Differentiation of this will give me minus 2x plus 4. So if I take 2x common, so I'll get 2 minus 2, I'm taking common x minus 2. So I cannot use here again. But yes, we can do one thing. We can use our mind to make it more shorter. Yes, what we'll do, we'll use substitution method obviously. Yes, see, we need differentiation of denominator is minus 2x plus 4. I can take minus 2x common, I will get x minus 2 I need. So x minus 2 I need in numerator. So what I will do here, x minus 2 I'll write extra. So plus 2 minus plus 2 I will have to add. It will be 2. 4x minus x square into dx. So I can write, I'll separate them now. X minus 2 into 4x square. No, it is not 4x square. It is not 4x square. It is 4x minus x square. So it is 4x minus x square dx plus 2 plus 2, 4, I will send them outside. So it will be 1 upon 4x minus x square dx. Now I think you can solve easily. Again here first part is solvable easily by substitution method. And for second part, what you can do, here you can use quadratic equation. Plus 4, I'll make as, I will take 4 common, so I'll get 4 upon 4 by x square. No, it is 4x minus x square, okay. So there is no problem, I will not take 4s common. So I'll take minus x as common, minus s common. So I'll write since I'll take minus common, so it will become minus x square minus 4x. So what I can do here, minus 4, I'm just solving second part. So minus 4 into, now I can solve them into quadratic equation. A square minus 2 into a into 2 is there. So again I need to write 2 square. I need to subtract also 2 square. So I will have minus 4 into 1 upon x minus, this is 2, x minus 2 का whole square, yes, minus 2 का whole square. So it will give me minus 4 into integration of 1 upon x square minus a square. The formula again will use directly, log x plus, our x is x minus 2 plus under root x square minus a square. Minus 2 square. Now there is no need to expand this again. For what you can do directly, see, by solving this quadratic equation, we are making this quadratic equation in the form of like this, under root x minus 2 ka whole square minus 2 ka whole square. So I can directly write log x minus 2. After solving this expanding, I will get x square minus 4x plus. So whatever part 1 will be, you will get here. So part 1 plus part 2 will give you required answer. Now this is 21st number. So we need to check again whether we can solve this by substitution method or not. The differentiation of denominator I will get 2x plus 2. Okay, so there is no benefit. Although I can try something like this, 2x plus 2. Can I get? But we can, there is no need to always find a and b. We can try how to substitute directly. What I can do, I can write x plus 2. What differentiation of this I am getting as 2x square plus 2. So I want to set up something like 2x plus 2. So what I will do, I will write 2x plus 2. So if I will multiply here 2, I need to divide by 2 also. So can I get something like that? No, I cannot do something like that. Here I need 2x plus 2 is there. So I need 2x plus 2 obviously in numerator, but it is x plus 2 is there. So I cannot try. So I need to use again the longer method, lengthier method we have to solve px plus q form. Now we will solve this by px plus q method, under root ax square plus bx plus c. So what we'll do here, we'll write x plus 2 as equal to a into differentiation of x square plus 2x plus 3 plus b. I'll get x plus 2 equal to a into differentiation will give me 2x plus 2 plus b. X plus 2 equal to 2ax plus 2a plus b. Directly here I am comparing, I am not writing anything. So value of a I will get equal to 1 upon 2. 1 upon 2 I will get, and then 2a plus b equal to 2. So a will be 2 into 1 upon 2 plus b equal to 2. So value of b will be 1. Okay. So now I can substitute x plus 2 by, I can write here integration. I can write x plus 2 by, I am replacing a into differential coefficient was 2x plus 2 plus b by x square plus 2x plus 3 dx. So what is value of a is 1 by 2 into 2x plus 2 plus 1 under root x square plus 2x plus 3. Now I'll separate this into two integration. I'll send 1 by 2 outside, it is 2x plus 2. See here, we have got ultimately 2x plus 2 in numerator, and we know that this is differentiation of denominator. That is why we are using integration to solve px plus q form, just to get in form of substitution method. X square plus 2x plus 3 plus this is dx, okay, and integration of 1 upon x square plus 2x plus 3. Again you can solve this by substitution method, and you can try this by either in the form of x square minus a square or a square minus x square or x. One of them you have to apply, not all three. Whatever it will be, you have to just try to change this quadratic equation in the form of x square minus a square or x square plus a square. Now we are moving on to next question, and whatever first and second part you will get, always try to solve like this. Then at last you can sum up by putting some equation. Yes, 1 plus 2 is our required answer. This is 22nd number. Okay, so again it is in the form of x plus 3 by x square minus 2x plus 5. So differentiation I will get 2x minus 2. So 2x minus 2 will give me 2x minus 1. So there is nothing we can do about it. So again I need to solve by linear method. That is in the form of px plus q. This type of question always takes so many pages, maybe more than 3-4 pages. So what I will do, I will write again x plus 3 as a into, I am directly writing differential coefficient of denominator. So it is 2x minus 2 plus b, that is a into dy dx of denominator, that is x square minus 2x minus 5 plus b. So I'll get 2ax minus 2a plus b. So value of a will be, directly I am writing a equal to 1 upon 2, and so minus 2a plus b equal to 3. Since a is 1 upon 2, so I'll get b equal to 3 plus 1, it is 4. Now I can substitute the value of a and b. I can directly write equal to integration x plus 3 upon x square minus 2x minus 5 dx equal to integration a into differential coefficient of denominator was 2x minus 2 plus b upon x square minus 2x minus 5. So what I will do here, I will separate what is value of a at first. It is 1 upon 2, 2x minus 2, and b is 4 plus 4 upon x square minus 2x minus 5 dx. So 1 I will send outside. I will break into 2 integration at first. 2x minus 2 by x square minus 2x minus 5 dx plus 4 into, I am sending 4 outside as it is constant, 1 upon x square minus 2x minus 5 dx. Again, this is first part. You can solve it by substitution method. It is quite easy. And this is second part. You can solve it by quadratic equation. That is, we can solve it like x square minus 2x minus 5. So x square minus 2 into a into b. So I need to write plus 1 also, minus 1 minus 5. So x square minus x square minus x, no, x, okay, wait, it will be x minus 1 ka whole square, yes. So it will become x minus 1 ka whole square minus 6. I can write x minus 1 whole square minus under root 6 ka whole square. So again, you can use formula of x square minus a square, and you know the formula for x square minus a square. It will be 1 upon 2a log x minus a upon x plus a plus c as our answer. So whatever 1 and 2 will come, you can add them, and this will be your final answer. So now moving on to next question. It is our 23rd question. Okay. Okay. So how many questions are there in this exercise? I think okay, 25 questions are there. Now right now we are on to 23rd question. Okay. So again, we'll try to solve it by substitution. 2x plus 4. Again, we cannot apply here. So what we'll do here? Again, we'll use linear method, px plus q under root x square plus bx plus c. So you will write 5x plus 3 as a into differential coefficient. You will directly write 2x plus 4 plus b. That is a into d by dx of x square plus 4x plus 10 plus b. So it will give me 2ax plus 4a plus b. Comparing coefficient of x both side, it will give you 2a equal to 5. So a equal to 5 upon 2. And so b will be value of comparing coefficient of constant both side will give me 4a plus b equal to 3. So b equal to, it will be 3 minus 4 into 5 upon 2. So it will be 3 minus 10. It will give me minus 7 as b, and a is equal to 5 upon 2. So now what I can do? I can write integration 5x plus 3 by under root x square plus 4x plus 10 as integration a into differential coefficient of x square plus 4x plus 10 is 2x plus 4. I am directly writing. You have to substitute it with this thing, the very first thing that you write after differentiating quadratic equation, plus b. Under root x square plus 4x plus 10. So now you can break this integration into two parts. It will be a, just put value of a at first. 5 upon 2, 2x plus 4 upon under root x square plus 4x plus 10 dx, plus value of b is minus 7. So I'm just sending constant outside. So it will be minus 7 integration dx. Here you need to write x square, okay, under root x square plus 4x plus 10. So we have 5 upon 2 integration 2x plus 4 by under root x square plus 4x plus 10 dx minus 7 dx by under root x square plus 4x plus 10. So this is first part, this is second part again. You can solve first part at first by which method? Substitution method you will try. Because the differentiation of denominator is numerator. So you can try. And this for second part you can apply. You need to try to make this quadratic equation in form of x square minus a square, or it can be a square plus x square, or it can be a square minus x square, whatever one of the form you have to use. So after getting 1 and 2, subtract them and you will get your answer. Moving on to 24th number. It is simple quadratic equation. You need to convert into at first required form. So it is dx upon x square plus 2 into a into b is here 1. So b I have to add also, subtract also, plus 2. So I'll get dx upon x plus 1 ka whole square, okay. And then minus 1 plus 2 I'll get plus 1, that is 1 square I can write obviously. So now it is in the form of x square plus x square, 1 upon x square plus a square. The formula for this is it will be 1 upon a is 1, 10 inverse x upon a. So it will be x plus 1 upon 1 plus c as our answer. We can check, I think it is multiple choice question. So we can see here 24th number, 10 inverse x plus 1 plus c. I think b should be then our answer. 10 inverse x plus 1, just 10 inverse x plus 1, we can check answer for 24th number. Okay, yes, b is there. So now we can try 25th number. So again it is in the form of quadratic equation. We need to convert it is in the form of required form. So what we'll do, integration dx upon, it is 4x square. I will take 4 as common. So it will give me x square minus 9 upon 4x, 4x, yes, it is fine. So I can write dx by under root, I can take under root 4, okay, leave it for here. I can write x square, okay, it is fine, minus 2 into a, okay, 2 into a is x, into what should I put b? B I should put as 8 upon 9. Then I will get 9x upon 4 minus I need to plus also, plus 9 upon 8 ka whole square. So I'll minus also, I'll subtract 9 upon 8 ka whole square and then yes, it is fine. So I'll get equal to integration dx upon, it is under root 4, let it be like this, it will be x minus 9 upon 8 ka whole square, ax square plus b square minus 2x into 9, okay, it is fine, minus 81 upon 64, so it is fine. So I'll get integration dx upon, I can send 4 outside, under root 4 will be, it will be 1 upon 2. So now I have got x minus 9 upon 8 ka whole square minus 9 upon 8 ka whole square. Now it is in the form of x square minus a square. The formula of this will be 1 upon 2 into 1 by 2a. 1 by 2a is 9 upon 8. So here I am writing formula also. Integration of 1 upon x square minus a square is 1 upon 2a log x minus a by x plus a plus c. So 1 upon 2a into log x minus a, x minus a, x, this is whole, x minus 9 upon 8 is x, x minus a by x plus a. Okay, it is under root, so I cannot use this formula. Formula will vary, okay. So formula for under root, I thought it is not under root. So under root is x square minus a square will be, wait 1 minute, what we have done. Okay, here it was 9x minus 4x square. So we have done mistake. So it will be minus 4x I have taken common, okay. It is minus 4. So it minus is there, so it will become plus and minus. Let me correct it, wait. So the formula will be using a square minus x square here. No, this is not the formula actually. So formula will use here integration 1 by under root a square minus x square, and this formula will be dx equal to sine inverse x upon a plus c. So here I will write 1 upon 2, it is fine, integration dx upon under root 9 upon 8 whole square minus x minus 9 upon 8 ka whole square. So it will give me 1 upon 2 sine inverse, what is x? X is minus 9 upon 8 by 9 upon 8 because a is 9 upon 8. So I'll get 1 upon 2 sine inverse 8x minus 9 upon 8, it will get cancelled, it will be 9 plus c. So we can check answer right now for 25th number. What is 1 by 2 into sine inverse by 2 into sine inverse 8x minus 9, okay, 8x minus 9 upon 9. I think B should be our answer. Yes, B is our answer. So we have solved almost all question of exercise 7.4. In the same way, I will cover all the remaining exercises of integration chapter. Once I'll finish integration chapter, then I'll move on to types of integration, so that it will be easier for you to understand why we are using particular method. Because once we'll solve whole chapter of integration, then it becomes very problematic which type of integration or which type of integration we'll be using, or which method we should use for particular type. So for that we need to know types of integration. Okay, I hope you liked the video. So please like and subscribe our channel Fun with Learning to watch more videos. I'll try to keep on putting some videos of lower class also in coming days. Okay, thank you, bye.